In this video, we're going to look more at how we can move blocks around a pickoff point. And so again, our goal here is the same as it was with being able to move blocks around a summing junction. Ultimately, we're going to want to get our block diagram so we have cascade, parallel, or feedback forms. We've not talked about those explicitly yet, but we're going to get there soon. And in order to do that, sometimes we need to just shift the blocks around pickoff points and summing junctions. So let's say, for instance, we have a block G of S as shown in the diagram here, and we want to be able to move this block G of S to the other side of this pickoff point. Well, again, we sort of ultimately want to keep these outputs the same. So we have R of S, G of S in the top, and R of S on the bottom two. So we know we want to have a G of S here. And again, that's maybe to get a cascade form or a parallel form or a feedback form. But we want all of our outputs to stay the same. So for this top one, of course, we don't have to have anything because that signal coming out of that block is already R of S, G of S, which is the same as what it was over here. Now, however, for the middle and bottom, we're going to have to multiply it by a 1 over G of S. And that's just because those branches didn't have that G of S before, so now we have to sort of cancel it out to keep things how they were. So the output signal here would just be R of S, again, the same as it was before. And then similar thing for our bottom case. So we have to add a 1 over G of S block here as well, such that our final output of that bottom branch is R of S. Now, of course, we could do the opposite. Maybe we have a G of S on the left side of the pickoff point and we want to move it to the right side. So the same basic idea applies. We want to preserve these outputs here. So in this case, they're all RS, G of S. So what we can do is just put the G of S in each of those three branches. In this case, we have three branches. Of course, the same idea applies to if we had more. So we would say in our middle branch, we're going to add a G of S. So this is our R of S input, and out of that then, of course, comes an R of S, G of S, and we have to add a G of S block here in our top as well, so that this stays R of S, G of S, and same thing in our bottom branch, we add a G of S block, and our output is R of S, G of S. And so again, our main goal here is we're preserving this output so that it behaves the same regardless of where this G of S is. And so an important thing to note regarding moving blocks around pickoff points as well as around summing junctions is that we're not changing the physical system. So not changing our physical system. All we're doing is we're changing how we represent it on paper so that we can do the analysis a little bit easier. So it's similar to the idea with circuit analysis. We do equivalent resistance or equivalent impedance. Of course, we're physically not going to the circuit and replacing those resistors with an equivalent resistance. We're just sort of on paper in calculations reducing that to make the analysis easier. So same idea here. We're not physically moving parts of the system. We're just moving the representation in our model.